Okay. So first, let me show you this. This is the formula sheet that you guys get during the AP test, which I haven't really worried about too much. I've just kind of written the formula on the board, you know. But probably about time to give it to you. So this thing up here, you'll notice, is what we write every time on in the math part of the confidence interval, the statistic plus or minus critical value times the standard deviation of the statistic. So you don't actually have to memorize that; it's on there. And then what we're going to do, the interval, a one sample t interval and two sample t interval. The t interval means we're working with means instead of proportions. And so the standard deviation of the statistic is just going to change based on what we're working with. So like we're doing this one now, right? PQ over n. Well, the next thing we're doing is two proportions. So you go down here, and that'll be the standard deviation. And we'll ignore this. We'll ignore this. And then we'll do sample means, and it'll be that one. And then we'll do two sample means, and it'll be that one. So we're really just kind of plugging into that formula in different scenarios. And the main concepts that we've talked about are done. We just got to go through like how to do it in these different scenarios. So that'll be your big test. And that'll probably be like the end of next week-ish. In the meantime, at the end of today, I'm going to give you a take-home quiz that's due Monday. So you'll have today. You can have some time to work on it tomorrow. You'll have school Friday. You don't have class Friday. And then you'll have Saturday, Sunday, and you'll turn it in Monday. And that take-home quiz will be worth half the weight of a normal test. So it's a little bit more difficult because it's take-home. I don't think it's too bad, but I don't think it's fair to weight it like a full weight because it is take-home and I'm allowed. You can work together on it or whatever. So, questions? What?
I just looked at mine.
All right. So on this packet,
Poor Maya.
Maya, I didn't mean to put the pressure on you, I guess.
We're just gonna hang it up.
You know what, Maya? I'm gonna do it on my own.
You should charge people.
I
will pay.
I would pay.
$20 an hour for my time. All right. So I want to do some of these to kind of get you started on some of the things we haven't talked about, or just go through a couple. But then I'm going to let you go after we do the ones I want to do. So I want to start with 1 and 2. I want you to try 1 and 2 right now. See what you can do. If you don't know how to do them, don't freak out. No big deal. These are the ones I want to go through together, and then I feel like hopefully if we go through these together, the rest of it should be not necessarily smooth sailing, but smoother. So you got to choose what's the smallest one that will guarantee. So you go to the next biggest one that's listed.
Oh, okay.
So you did it right. Don't freak out. I'll start right now, number 2. You guys are finishing up. And then 1 I want to talk through. So for the second one, it is kind of like disconcerting because you get a number that's not really close to any of them, but that's okay. So this is your margin of error formula, and that equals MOE. So then this is my inverse norm of 1.95 divided by 2. They didn't tell me P, so I use 0.5, right? You just gotta go in the middle because we don't know what it is. N is blank, and then 0.08 is what they tell you. So then I divided by 1.96 to get to here. What did I do in this step? I squared, and then I do that like flip-flop deal I showed you yesterday, and I get 150.05, so I need to ask at least this many people, and so you just go to the next biggest number, so it's, how many got 150? Alright, does that make sense why it's C? You're just going up to like the next one, you need at least that many. And they make it reasonable, they wouldn't put like if this was 150, I would have freaked out. I wouldn't know what to do because it's like 150.05, so I would have thought they won't do that to you though. They'll make sure it's like a reasonable distance apart. Questions on 2? Alright, then 1, we haven't quite talked about this, we have a little bit, but I got, my first interval has 9,000 in it, and then I go to an interval with a sample of 1,000. So if my sample size, we usually talk about the other direction, if my sample size gets bigger, what happens to my margin of error? Is it gets smaller. Well, they flipped it. So if my margin of error, if my sample size gets smaller, what's going to happen to my margin of error? It's going to get bigger. It's the same concept, it's just backwards. So usually we talk about a bigger sample size leads to a smaller margin of error. Well, now we're just saying a smaller sample size leads to a bigger margin of error. But you have to be careful. You got to remember that the n is underneath a square root. So it's very tempting to look at this and say, well, it got 9 times, my sample size got 9 times smaller, so my confidence interval should get 9 times bigger. But it doesn't, because that 9 is under a square root. So it doesn't get 9 times bigger, it gets the square root of 9 times bigger. And they always give you like 4 or 9 or 16, because they know you have to take the square root of it. So that's another like kind of clue that that's what's going to happen. So this answer is actually B. If you got to the point that it's wider, I'm pretty pleased with that. So if you got down to A or B at this point, I think that's good. But then just remember it's underneath a square root, so you got to do the square root of that 9. How many had B? Anybody? How many had A or B? Okay, that's cool. Questions on 1 or 2? All right, let's jump to number 6. No, sorry, number 8. Before I do number 8, let me talk for a second. Let's say a survey in this class. What percent of you think lunch should be longer? Then we got to do 5 minutes. Let's do it. Raise your hand if you'd like a 10-minute longer lunch. But that also means that school you won't get out until 10 minutes later. So you can stay here for extra 10 minutes just during lunch. How many would like a 10-minute longer lunch, but you don't get out of school until 2:21? Just somebody. I need something. Yeah. Okay. So all right, that didn't work very well. But let's say that my confidence interval was 0.2 to 0.3. And then someone says to me, is it reasonable to assume the true population proportion is 0.28? Is it reasonable to assume that? What would you say? Remember, this is our attempt to capture the true population proportion. So we're pretty sure the true population proportion is somewhere in these two numbers. Is 0.28 in between those two numbers? Yeah, so that is reasonable to assume. If I said, is it reasonable to assume the true population proportion is 0.4? Since it's not in between those two numbers, you would say no. So you can kind of use this as a way to test or kind of guess, kind of answer a question like, is this reasonable or not? You see the polls on CNN, so we took a poll, and we're pretty sure 60% of people, plus or minus 5%, want marijuana to be legalized. Is it reasonable to assume that more than half the people want marijuana to be legalized? Yeah, because every number in there is more than half, right? Is it reasonable to assume 75% of people want to be legalized? No. Is it reasonable to assume? Do you get what I'm saying? We're good. Okay. So try number 8 then. With that. Keep that in mind. Okay. So a 0.52 plus or minus 0.04 would be between 0.48 and 0.56. So the main thing to realize here is 0.5 in the middle of that? It is. So I can't say that, if this entire interval were to be above 50%, if it were 55 to 65, then I can say, okay, I'm pretty sure more than half the people are going to vote for Smith. But since 0.5 is in the interval, I can't say that. And this is actually no prediction can be made about who will win because 0.5 is right in the middle of that. So I see people erase them. Can I talk through what was, you picked D? So there would be convincing evidence he would win if this entire thing were above 50. If they were 0.51 to 0.59. So the 0.52 is bigger than 0.5, but when you throw the margin of error in there, you know what I'm saying? Does that help? Is that alright for that one? Alright, go to number 9. Try number 9. Think about the wording that we use when we write out those essays. And a very key phrase that I make sure you put on the essay actually twice. So the whole point of a confidence interval is we sample a small group of people. We try to use that information to make a generalization to like the big population, right? So in the essays, when I have you write it out, we say we want to estimate the true population proportion. Like I'm always looking, I take my sample, but I'm using that sample to try to gain information about the big picture, the whole population. So basically, if these answers say sample in them, they're wrong. Like you want to try to find the population proportion. So in A, we're confident the sample proportion. No, I don't care. I don't care about the sample proportion. In B, so it doesn't say like the true population proportion, but it says the proportion of all citizens. Isn't that pretty much the same thing? So let's keep that one in mind. That might be a possibility. This one says sample proportion. No, that's out. This talks about 95 of the intervals will be identical. If I just keep taking like over and over samples, will the samples all be identical? You know, if you go ask 70 different people the question you asked them on Monday, will you get the same thing every time? No. And then this one says sample proportion also. So, and this happens a lot. Like you can eliminate sometimes all of them, sometimes all except one. Just by like, if it says sample, we'll get rid of it. We're trying to gain information about the population. Does that make sense? One more. Go to, I'm sorry, two more. Go to 15. Population doesn't quite help you as much in that one. Helps, but not as much. Why is yours yellow?
No idea.
Did you paint it yellow? Is that even yellow? What color is that?
Yellow. Well, a couple of them are white. I have a few white pages and mostly yellow.
So, and think about this with the sample that you guys did. Like you went and asked 70 people a question, and is it a guarantee? So it's a 99% confidence interval, but is it a guarantee that the population proportion will be in your interval? It's not a guarantee. Is it 99% likely? Is the probability 9? That's what you want. The probability is 0.99. So if you did it over and over and over again, 99% of them would contain that. I deleted C and D because they say sample. And this is the idea I deleted. This is saying like my sample proportion is going to be exactly, like forget the margin of error, but just exactly the population proportion 99% of the time, and that's too extreme. Like it'll capture the mean somewhere in those bars 99% of the time, but it's not going to match exactly. It might, but not 99% of the time. How many had B there? Questions on it? All right, one more. Do 17. So the point estimate here is 0.4. Is that, and I'm not necessarily figuring it out yet, but I'm going to need to in a second. Is the point estimate there bigger or smaller than 0.4? Point estimate's right in the middle of those, right? So it's smaller. So the summer interval, which one's the summer one? The 0.4? So the summer interval has a greater point estimate. So let's start there. So that gets rid of two of them. And then, so the idea now is the interval going to be wider, narrower, or the same width? So that's what we're trying to get between. So, remember that the point estimate goes in your margin of error calculation. So like if my point estimate is 0.4, don't I also put 0.4 there? And then the opposite of it goes there. So do 0.4 times 0.6. Don't need a freaking calculator for that. That's 4 times 6, for God's sake. What's 0.4 times 0.6? 0.24. Take a second and find that point estimate. How do you do that? It's the average of those two numbers, right? So add them up and divide by 2. 0.11, yes? Alright, if P is 0.11, what's Q? 0.89. Do 0.11 times 0.89.
0.097.
So what I'm figuring out right now is the top part of this, which is in the margin of error calculation, right? So which one of those is going to result in a bigger number here, the 0.4 or the 0.11? That's not making sense. So if I put 0.4 here, forget the z star, forget the square root, forget the square root of it, or the divide by n, because all that stuff's the same no matter what my point estimate was. If I put 0.4 here and multiply, I get 0.24, right? And then divide square root times z, whatever. If I put 0.11 here and multiply, I get 0.0979. And then divide square root multiply. Well, which one of those gives me a bigger number right here? The 0.4 does. So which one of those gives me a bigger number for this entire piece? The 0.4. So which one results in a wide? Does 0.4 result in a wider confidence interval, a narrower, or the same? Why? Because you put a bigger number in there, it's going to make your margin of error wider. That's part of the reason we use. That's the reason we use 0.5 here also, because it gives us like the most margin of error. If we don't know it, we use 0.5. So it gives us the biggest margin of error. I got fingerprint smudges all over it. That's a tough one. But so that's B. Alright, that's all I wanted to go through. Tomorrow when you come in, I'm going to have you submit your answers into the Google Forms. So this is homework. And I will give you the take-home quiz tomorrow. So I want to come in, have you submit these, go over questions, clear up any misunderstandings, whatever, and then I'll give you the take-home quiz after that. So I know some people are missing tomorrow. Is that why your hand was up? So I'll give it to you now. So here's the quiz. You just need this one. Tomorrow? Okay. So I will also put the answers to that on Schoology because it might be helpful so I can know if you can